So today we're going to start in chapter 9 and we're only going to get through a couple sections and that's okay. We'll be in 9.1 for a couple of days. So to get us started, we do need to talk about how to count because combinatorics is the math of counting different objects. So we're going to use that to help us go through and find out different ways we can combine them or order them and do lots of different things with them. So there are a few things that might come up throughout some of our assignments, and so some of these are miscellaneous, some of them are more specific, but the bigger point is there are a lot of things on this list that we might not know off the top of our head, which is why Google is our friend to help us find out, hey, what are some of these things, because I'm not sure. So for example, how many cards are in a standard deck? That's going to be 52. Cards in each suit in a standard deck of cards is going to be, there's 4 suits because there's 13 in each. How many faces are on a cubical die? A standard dice has 6 sides. How many possible totals can we have when 2 dice are rolled? And so you could list those possible totals out. You could have 1 and 1 that add to 2. You could have 2 and 1 that add to 3, and so forth. How many possible totals are there? That's actually going to be 11 possible totals. And then what are the number of vertices on a decagon? And that's 10 when it shows up. It's taking a second for it to connect from my computer. And so it's going to take a second to show up. It should be 10. And so the number of musicians in a string quartet would be 4. And then number of players on a soccer team is 11. And then number of prime numbers between 1 and 10 inclusive. Inclusive means I can count 1 and 10. And so prime numbers, and this is something to pay attention to for the sake of the online homework, 1 is not counted as a prime number because the definition of a prime number is 1 and itself, and so 1 is in one of those weird categories. So prime numbers would be 2, 3, 5, and 7 between 1 and 10. So that gives me 4 numbers between 1 and 10. And so it was a trick because it said inclusive, which means I could count 1 and 10, but 1 is not prime and neither is 10. So like number of squares on a chessboard, that's something I do not know off the top of my head. If that is something you know, awesome. If you don't and it comes up in a problem, please Google it, okay? So in this case, it's 64 squares on a chessboard. And number of cards in a bridge hand per player. This is something I had no idea about before doing some of this research through your book for the lesson. And that's going to be 13 cards. Because evidently you deal out all the cards. But, so if you don't know things that come up, just go and write them out. So, take a moment and think about how many different 3-letter codes can be used from using the numbers, the letters A, B, C, and D if no letter is repeated. So, for example, if I write A first, I could write A, B, C. I could have A, B, and D. I could have A, C, and D. I could have A, D, and B. I could have A, D, C. Okay, so those are all the options I have to list off for just A coming first. But then I would need to go through and list what happens when B comes first, what happens when C comes first, and what happens when D comes first. Okay, so if I list all of them out, I have 24 possibilities. So it is best if you find some kind of pattern to write them out so you don't accidentally write the same order twice. So this was a 4 by, I had 4 different rows and 6 different columns, and so because of that there's 24 possibilities. We will talk about better methods to find some of these other than sitting there and listing out every possible value. So looking at that, one way I like, and we'll see this principle in a minute, is for this particular one, instead of actually listing them all out, I would make blanks for however many I have. So in that first spot, right now before I pick a letter, I have 4 letters I could choose to pick from first, and I'd pick 4. Okay, well now, say if I picked A, I only have 3 letters left I'm allowed to choose from for the next value. So then I would have 3. And then last but not least, if I've already picked 2 letters, I only have 2 letters left to pick as my final option. So I would put 2. And multiply all those together, I do get my 24 possibilities. So that's the multiplication principle that you will see later in this lesson. Okay, so another way to help you list them out orderly, instead of going, oh, let me list A off first, you can also build a tree. And so this is another way to get the same answer. And so what a tree does is, in this case, I said, okay, well, I have A first, B first, C first, and D first. Then I'm just going to zoom in and just focus on the A branch. I could go A, B, C, or I could go, I'll change colors, or I could go A, B, D, or I can go A, C, B, or I can go A, C, D. And so you can continue this on that last one, and so that you can see, hey, I did have 6 different options, and the tree makes it just a little bit more organized so you don't lose information as you're going. You could do that for each of those and see how many options you have total. So honestly, trees take a while. I only do it in situations in which I have multiple different levels of things, but it is good to know how to build a tree and what makes sense. So this kind of topic is stuff that's going to be used for those of you who take stats, and for those of you who have to take like a miscellaneous math class your freshman year of college. This is often covered in one of those math classes. And so it's nice for you to have like a little bit of an intro here, even though it's short, just so you see some basics before you get to a college course. So the multiplication principle of counting is that the verbiage sounds more mixed than others. So what we did was P is going to be the sequence of stages. So for example, S1 was like picking my first letter. Okay. And then S2 was picking the second letter. Okay, so what we did was, okay, I picked the first letter. I had, in the example we just did, I had 4 options. So that's when I drew out the blanks. Okay, so my R2 was I had 3 options because I already picked one and I wasn't allowed to repeat. And then you do that for however many you have, and then you can multiply all those numbers together. I do it using blanks because it lets me know what do I have to fill in, what do I need, what do I have. So let's go look at an example other than just using the letters. So the multiplication principle is find out how many ways can each stage occur and then multiply those values together. Okay, so if you need this slide still, hit pause. I'm going to go ahead and move on to the example. So if we have a license plate that has 4 letters followed by 3 numerical digits, find the number of different license plates that can be formed if there's no restrictions on letters or digits that can be used. Okay, so numbers, so I had 1, 2, 3, 4, all of these need to be letters. Okay, and then it also told me I have 3 numerical digits. So I'm just going to put N for number. Okay, so this is one of those times that you have to remember some of those finer details. So how many digits are in the digits? How many letters are in the alphabet? Well, that's 26, so I'd have 26. It said there's no restrictions. That means I'm allowed to repeat. I can keep using the same letter if I wanted to. So A would be allowed. Because of that, I don't need to reduce that number like I did in the last one when I was told I couldn't repeat. So this would give me 26, 26, 26, and then digits. So remember, it's 3 individual digits. 10 wouldn't count as a digit. So digits I have would be 1 to 9, but also 0 counts as a digit. And so that would be 10 different digits. So that would be 10, 10, and 10. So please, please, please use your calculator, because I do not expect you to now go in here and multiply all of these together. So using your calculator and double checking you typed in the right stuff, because it's easy to not type in the right things, you would get the value of 456,976,000 and 3 zeros. Okay, so that's how many possible different license plates we have if there were no restrictions whatsoever. Realistically, there are restrictions. Certain states don't use certain letters. Some states might not use O or 0. They might only use one of those. And not to mention, letters and numbers normally get mixed in together. Maybe certain states don't want repeated numbers or letters. It all depends on the state restrictions. So let's go ahead and look at another one. So, that's the solution. So, as we keep doing these, permutations are an n set, and so it's when you use all the things. So, for that first example, when I had letters, I had more letters than I had spaces to fill. Or the license plates, I had way more letters and numbers than I had spaces to fill. So, because of that, they don't join this set that we're looking at next. Okay, so first we're going to start with our basic permutations, and so this one works only if you're using everything in the set. So if you have 10 items and you're using all 10 items, this formula works. Okay, so n factorial, and this is how it relates to our multiplication principle still. Okay, n factorial means n times n minus 1 times n minus 2 all the way down to 2 times 1. Okay, so for example, 4 factorial is 4 times 3 times 2 times 1, which is 24. Okay, so let's look at an example that's a little bit more specific. So this one has an 8-letter word formed using the word computer. So computer has sometimes I forget to hit that button. And now you have the answer. We're going to pretend you didn't see that. So computer has 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 letters, and with the 8 letters, none of them are repeated. So I don't have 2 T's like the word. My mind just blinked about, or like the word letter. There you go. And so because there's no repetition, that helps us. When there is repetition of a letter, we have to look a little differently. But because I'm using all 8, I have 8 letters, I have 8 words, so we're going to use 8 factorial, okay, which is going to be, in writing it out, it would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, okay, so this total is 40,320. But that's not always very helpful, because that's a lot of time that you have to use to go in and do that. So, in your calculator, okay, give me a moment, I'll pull one up. So, we do have the option in your calculator to pull up the probability section. So if you hit the math button, it brings up an options. And so if you scroll over to the PRB, it's going to bring up a list that has to do with probability. And so notice number 4 is that exclamation point. So if, I hit enter on the wrong one. Sorry about that. I have to go back in there. And so, well, right now I have a factorial because I didn't do anything first. So I'm going to do second, insert, and 8. So it's easier if you type the number in first. But now I'm going to hit enter, and I'm going to get the exact same number that was my answer a minute ago, except I didn't have to type in 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so it saves you a minute in having to type it in by doing just a few different clicks on your calculator. So let's go ahead and do another example right quick. And we're going to talk about permutations when we don't use all 8 of them, okay? So when we don't use all 8, what we can do is we have this formula. And so, for example, when I had the letters, okay, so when I had 4 letters and I picked 3, okay, and so because of that, this one order mattered to where ABC was different than BAC because they're the same 3 letters but they were in opposite. And so in this case, the 4 letters is N and the number I am using is 3. Okay, so calculator wise, I would have typed in 4P3. So bringing my calculator back in, let me give the screen a moment to catch back up. Oh, I'm going to have to get rid of that screen. So this is going to go away, but remember 4P3, so my calculator can come in. Okay, so I'm going to hit math, and then I'm going to scroll over to the PRB. And I have the NPR as my second option. I'm going to hit enter on it. Well, you have to type in your first number first. So I had my 4 NPR 3. And so that goes through and does the formula for me without me having to do it. So 24 was my answer earlier. We saw it with the multiplication principle. We saw it with listing them out. But this one's even faster because I have 4 letters. I'm picking 3 of them. Okay. And so this is a permutation formula. So if I did second entry, if I chose 4, okay. So we already know 4 factorial was 24, okay? So if I did 4 choose 4 for permutations, it still gives me that 4 factorial, so you won't always have to use the, ooh, am I using all my letters? You can always use this one and it takes care of it for you using the actual formula. And so let's go ahead and go look at an example. So we're choosing 4-person committees that can be formed from a group of 20 people, okay? So one is president, we have vice president, secretary, and marketing manager, or student life representative. So we have the 4 different offices, okay? And so because of that, does the order matter? Yes, because president is going to be different than vice president, and vice president is different from secretary, so the order mattered a good bit. That's what you want to start asking yourself with these. Order is a permutation if order matters. We're about to get one where order doesn't matter, and that's going to come into account. Okay, so for this one, we're going to use our permutation of, I have 20 people to pick from, but I only have 4 spots to fill. So in your calculator, it would look like 20 NPR and then 4, okay? So I'm not going to show my calculator this time, but I am going to type it on my calculator to get the answer. So if I did 20 choosing 4, I have 116280. So I have 116,280 different ways that we could apply those if everyone ran for each office. Okay, obviously they don't all run for each possible office, but at the initial list, that is the possibility for how many we could have. Okay, so let's talk about the difference with actually using a combination. Okay, so I have to wait for it to catch up. I don't know why this is going so slow today. So what's called combinations is when order doesn't matter. So for that list of writing letters out, that would be like when A, B, and C, but if I had A, C, B, we'd count it the same. If I had B, A, C, anything that used the letters A, B, and C together is considered a duplicate. And so, for example, if we have a group of people and maybe they don't have titles and they're just all on a committee together, because of that, if there's no special location, that would be when we have a combination and not a permutation. So with that, we would need to use this formula instead. So just to go in and use that idea of numbers, the letters that we had. So when I had 4 choosing 3 letters, what happened? So this is 4 factorial over 3 factorial divided by 4 minus 3 factorial. So I know I didn't write the other one out, but I think it helps for us to see what happens with this one and why it's different. So this would be 3 times 2 times 1, and 4 minus 3 is 1. And so when we work that one out, the 3, the 2, and the 1 cancel out. So I'm just left with 4. And so out of all of those letter combinations, it means it's actually only special for when I only have 4 special ones that were unique and different than all the other ones if order didn't matter. And so because of that, that's why we have to take it into account. So a specific example that would mean it, I had a 4-person committee in which can be formed from a group of 20 people, okay? And so how did this end up applying together? So this would be, this would give me 20 choosing 4 people, okay? So this is when they don't have titles, they're nobody special, okay? There is the option in the math under the probability that is NCR, which is the 3rd option down. And so if I go in here and had my 20 and then did NCR and then 4, that gives me 4,845, which is a significantly less number of possibilities than we had earlier. And it's all due to the fact that I just didn't have as many ways to combine them to make it a unique committee. So with that, let's go ahead and go look at if I did a committee of 10 people, okay? And so if order doesn't matter because they didn't have titles, they weren't special, that's going to make it a combination. And so, oh, it hasn't shown up yet. And so when you have combinations, it makes it special. So that's what you're going to be deciding. We're going to start off with some basic problems tonight of, okay, is it a permutation or a combination? Which one? So think about order. Does order matter? Is there specific titles? Is there a specific way we group them? And that'll make it different. Oh, here it is. It finally caught up to me. So when there's a 10-person committee that can be formed from 20 people, here's the way you could write it out. But really, use your calculators. They're your friends here. Yeah, so let me know if you have questions. It's a short assignment. Seniors, yes, you have to fill this one out. I'll just do it before Friday because then you're done. I'll just do it Thursday. But let me know. I'm here to help y'all if you need it. Have a good day, guys. Bye.